So I'm calling this section mutable arguments in functions, and the reason why we're calling it mutable arguments in functions is because we've got a argument here which is L, and we want it to be of type list, and we've got this blank list, and lists are mutable in Python. So one thing that we're going to try to, at least we'll hover over this function. We see we've got a function, it's defined, it's got its name, it's called f here. And A, which is the first value, is of type any, so anything can go into the list. And then L is supposed to be a list, and here it is defined as an empty list. But the thing is, the Python interpreter hasn't interpreted it as a list, it's just taken it as any. And also here, when we do, and if we are to do just over here, L dot, it doesn't know what L actually is. It could be anything, so it doesn't know it's of type list. So the first thing we'll do is this type inference, or type hinting it's called. So we'll type hint it to a list. So now this is turned yellow, and also if we do L dot to expose a method, it's seen as a list. So we're telling Python, we're telling the interpreter, and we're telling the users that we're expecting to get a list now. And when we hover over the function, it's a little bit cleaner. L is of type list, and it's pointing to this blank list, and we're returning back a list. And we're going to append to this list, and when we run our code here, we see that we get a 10 over here, and then a 10,1 on the next line, and a 10,1,99. And the reason why we're getting that is because we set this result, and it's equal to f of 10, and f starts off as this blank list, and then we're putting the value of a into our function, and the other variable that was here is actually list itself. So we've got this empty list that's come in, and this list must be occupying the same part of memory in order for it to be incremented, and that's the mutability part. Our collections can change their sizes, but they still point to the same space in memory, and we can actually show this by putting in a print statement over here. So we can do a print of the ID of L, and we will see that each time the ID of the list is the same ID. So it didn't matter whether we put in, refed back in the same list. So on our subsequent calls to the list, we might have put in back our original result, but it wouldn't have mattered. It never made a difference because it's still pointing to the same point in memory anyway. And that's one of the examples of the mutability of lists, and where we can use it to our advantage. If we wanted to do that, we're always appending to the same list. What we'll see in the subsequent method below is that we've actually got the choice. We can always append to the list, or we can decide to create a new list. So create a new list in a different part of memory, and then append to that if we wanted to. And the format will just be slightly different, as in we call the list in it, or we create the list in a different way inside of memory, and we can pass it in if we want, so retain its position in memory, or we can create a new list inside the function. So that's generally speaking the mutability, or putting lists or mutable types as arguments into functions, and one example of a use case of that.